10-1, areas of parallelograms and triangles. Okay, here's your first illustration. Name this shape.
Oh, rectangle.
It's a rectangle, okay? Come back to me. What is the formula for the area of this figure? Length times width or base times height. Okay, we're doing base times height. So the base times the height, right? Here's your base, here's your height. Okay. I have to. Okay, notice rectangle. What is that figure?
Now it's a parallelogram.
It's a parallelogram, okay?
What? That is not the same.
So I took it here, right? And I just moved it over to here. Did the area of this figure change at all?
No.
No, I still have the exact same amount of stuff, right? Okay, so consider then the area of a parallelogram is the exact same formula. Where's my height?
Your height is in the thing, right there where the cut is.
My height is still this side, right? If the rectangle was base times height, and I move this over here, this is not my height, right? That's a slant. My height is perpendicular. My height is the space. That slit is my height, okay? So that's the first thing we're going to do is just write out these formulas. So first one, area of a rectangle is A equals B times H when my rectangle looks like this. Okay, a rectangle has 4 right angles. My base is one side. My height is another. Honestly, it doesn't matter which one's your B and which one is your H. Commutative property of multiplication says you can multiply in any order. So base times height will be your area, okay? Then, area of a parallelogram. Remember my abbreviation for parallelogram looks like that. Same formula. Area equals base times height. But the biggest mistake that I see made on these is people call this the base and then they call this the height. And that is not the height, okay? The height is the same. Like I just showed you, it's still got to be the perpendicular. So if I draw a perpendicular in here, this will be my height, okay? Make sure when it's a parallelogram, you are not using the 2 sides of the figure. It won't work, okay? The only time it will work is if that parallelogram is a rectangle. So we are going to do that. Just make sure your height is perpendicular. Sorry. Okay, so let's go through a few. Oh, one more. If this is a square, okay, 4 right angles, 4 congruent sides, and I call the length of a side S, what's the formula for the area of a square?
S squared.
S squared, right? It's S times S. It's still base times height, but our base and height are the same. So we can just write that as area equals S squared. Okay? All right, so let's do a few of these. Let's say I have this figure where this is 4.5, this is 5, this is all going to be in inches, okay? Okay, so those are the sides lengths that we have. If I want the area of that figure, that's a parallelogram, okay? What's the area of that parallelogram?
20.
It's 20. And then here's the deal, guys. Units are huge in this chapter. If you don't label inches or inches squared or whatever your units will be, you will get points taken off. So make sure you get in the habit of labeling everything, okay? You have base times height, okay? Your height would be the 4, not the 4.5. So there are going to be times where there are numbers there that mean nothing to you. It's just there as a distraction just to see, do you actually know what you're talking about? So ignore the 4.5. You do 5 times 4. So our area is 20. And then when you're labeling area, it's always inches times inches, or feet times feet, or yards times yards, whatever it is, which would be what?
Inches squared.
Inches squared. Okay, so 20 square inches would be my area of that parallelogram. What would this one be? That's not pretty. Okay, so these are all centimeters. I'm not going to write centimeters behind everything. But you have a parallelogram. Okay, they will tell you it's a parallelogram. They'll say, find the area of the parallelogram. What is your base and what is your height?
2 centimeters to base and 3.5 centimeters.
Okay, so here's the thing. The base of a parallelogram is a side of the parallelogram, right? So even though there's that extra 2 there, that's not part of the parallelogram. That, again, is just there to distract you. We don't need it because the side of our parallelogram is 2. So if this is my base, okay, that would be B. Then what's the height? 3.5, okay? The height is not necessarily a side. In fact, it probably isn't if it's just a regular old parallelogram. So again, we don't want the 4.6. We want the perpendicular, the 3.5, and the base, okay? You're taking pictures of. So you're going to do area equals base times height. So you get an area of 7 what?
7 centimeters squared.
Correct. Yes, sir.
Does anything squared, like, would that be 7 centimeters size squares? Is this area?
Yes. Yeah. Yep. Okay. Then we get a little bit fancier, but with the same equation. Let's say you have this set up. This one's a little fancier to draw. Just extend that side and then make this one perpendicular to it. So this is D, F, C, B, A. And then here are the units you have. So this AB side is 10 inches. AD is 13 inches. The perpendicular is 12 inches. Okay. And they're going to ask, what is the length of CF? So first thing I would do is just put an X there. Because for some reason, when it's an X versus a segment CF, people see it better. So I would put an X right here. And then we have to figure out what is that length. Now, if you're looking at the picture, trying to find a base and a height, do you see a base that has a height corresponding to it?
10 inches.
What's the height? 12, okay? So we can find the area right now of this figure, which is not what they're asking us for, but we need it. So if I find the area, I'm gonna do base 10 times height, notice it's perpendicular, 12. Okay, so I know the area of that parallelogram is 120 square inches. Okay, if I use a different base and height, does my area change? No, it's still the same area of the figure, right? So what we're gonna do is, now we know the area, can you find a different base and height that correspond to each other? What's the other base and height? If 10 was my first base, what else could I use as a base? 13, okay? So I can use 13 as my base, and then the height that corresponds to that is whatever's perpendicular to that, which is my x. Okay, so you have two bases and two heights in this picture. I know that the base times the height and the base times the height are equal because it's the same parallelogram. So what we're gonna do is we're gonna say, if the area equals base times height, what's A? 120, that's what we solved for already, okay, 120. What's B? B is 13, and then what's H? X, okay? All you have to do then is divide by 13 to solve for that x. So you do 120 divided by 13, and that comes out to, we're gonna say it's approximately, because we're rounding, 9.2 centimeters. Okay, so you have a base and a height, and a base and a height. If you find the area, then you can use that area to find the missing piece. Questions on that? All right. Next. So that's parallelograms. You're going to do a lot with that. And then you're also going to do a lot with this, area of a triangle. Can anyone tell me the formula for the area of a triangle?
The area of a triangle is base times height divided by 2.
Right. So some people, I feel like coming from, they must do that a lot in the middle school that way, BH divided by 2. Totally fine. It's just not how I ever do it. So don't let me throw you off. These are the same thing, right? Same formula, just written a different way. So if you prefer to do base times height and then cut it in half, go for it. If you do like 1/2 times base times height, that's fine too. They are the same. Think of it this way. If I have a parallelogram that is base times height, and I cut that parallelogram in half, that means this is the base times the height cut in half, and this is the base times the height cut in half, right? You get 2 triangles out of 1 parallelogram. So you cut that parallelogram area in half, okay? That's where that formula comes from. In a triangle setup, your base can be any side, okay? So let's say this is my base right now. My height is always perpendicular to it. So I can't use a side unless it's a right triangle. My height here would have to be that line. But say I had that same triangle, or somewhat that same triangle, and I wanted to use this as my base, my height is the perpendicular coming this way now. Okay, so you just have to make sure that your base, whatever you're using as your base, your height is perpendicular to that base. Okay? All right, let's try one. Let's say our triangle it's a little crooked, sorry. So our triangle looks like that. If I want to find the area of the triangle, we need my base and my height, and then we can plug that into the formula 1/2 base times height, or base times height divided by 2. How many of you would prefer base times height divided by 2 to 1/2 base times height? A few of you. Okay. I honestly don't care which way you do it. I don't know that I can physically do base times height divided by 2 because I'm going to forget, because I've been doing it 1/2 base times height for 13 years. So, sorry. Mm-hmm. Yeah. But if you want to think of it that way, that's totally fine. So here's the question. If we're doing 1/2 base times height or base times height divided by 2, what's your base, what's your height in this picture?
Your base is 10 feet.
Mm-hmm.
Your height is 6.4.
Okay, so this is B. This is H, right? Because it's perpendicular to my base over here. Okay? So you would do the area equals 1/2 times the base, which is 10. Okay, this is B, times the height, which is 6.4. That's my H. So 1/2 base times height, you get an area of what? Well, I'll give you the number. 32 what?
64.
Right.
Divided by 2 is 32.
So just make sure square feet when you're finding area. Okay, it's always squared. Questions on that? Yeah.
Will the calculator not only do the half to the 10, or does it also have to do the half to the 64?
When you're multiplying, it's not good. You don't distribute, right? You only distribute, like if it was 1/2 times 10 plus 6.4, then you're distributing it. But when you're multiplying, you're just saying 1/2 times 10 times 6.4. So you can cut either one of them in half, but you don't cut both of them in half. Okay? Ignore that. You're not doing that. Okay. What do you do with this one? Here's a question for you. Anybody know the length of the hypotenuse right now?
It's
It's a Pythagorean triple.
560.
No. 169. Square rooted.
I don't know what that is, but that's the answer.
Did you plug it in?
169. 13.
Good job. So 5, 12, 13. Let's say you have these lengths. I'm not going to make you find the third side. I just was curious if Pythagorean theorem was still with you. What would the area of this triangle be? Or what are your base and height? Let's start there. What's your base? What's your height? Right. So you may use 5 and 12. Honestly, because they're perpendicular, it does not matter which one is your base and which one is your height. But you could say this is your base and this is your height, just because that's the places they usually are associated with. So your area would be 1/2 times 12 times 5. Okay, the 13 does not get used. You want the two that are perpendicular. So when your triangle is a right triangle, you'll actually use two sides of the triangle. Okay, so work that out. You get your area is 30. We were talking centimeters, so 30 square centimeters. Questions on that? Okay. And my favorite problem of the day.
Is it because it's homework and we're done?
No. We're almost done, though. Okay. I want to know the area of that figure. Talk me through it.
Okay, so first you wanna do 5 times 12, and then that answer
What is that getting you?
is 60, ooh. And then,
The area of the rectangle. Okay, hold on. So if you start with the rectangle, right, this one here, you have a base of 12 and a height of 5, right? So the area of the rectangle is going to be base times height, or 12 times 5, which is 60 square centimeters. Okay, so that's part of our answer. Then we need the triangle.
so you go 16 minus 12 equals 4, so that's your height of the triangle.
There you go. Okay, so
Base is 5.
you have 16 is the whole length here, and 12 is this length. That means this length, this leftover little remnant, has to be 4, right? You go 16 minus 12 is 4. So I know this length is 4 centimeters, which means that this length is 4 centimeters. Okay, so we know the height. What's the base?
The base is 5 centimeters.
The base is 5, same as this one over here. So to find the area of the triangle, you would do 1/2 times 5 times 4. Okay, so 20 cut in half is 10 square centimeters. Okay, and your calculator will do all of that for you. Don't feel like you need to do it in your head. No need to make silly mistakes on things like this. So I know this is 60 square centimeters. I know this is 10 square centimeters, which means the whole thing is what? 70. So your whole area would be 70 square centimeters. Okay, just add those two parts together. Questions on that? Alrighty. You have 17